Okay. Somebody asked what I was working on in the comments. Working on a few things here. So, first we've got, this is the PMA test suite. This work is actually public. You can actually go look at the PMA on the Nockchain GitHub. I don't recommend you try using it until I'm done validating it, but that effort's pretty far along. Let me get the name of the branch here. Yeah, so this branch here, bump PMA post throughput event log of snapshots. I implemented 2 different versions of the PMA. We horse raced them against master. Throughput was better for reasons that made sense. Basically, we don't have to, in the final flip top frame, we don't have the entire subject at the bottom of the knock stack anymore. It's off heap in the PMA now. So it makes the last compaction on the last flip top frame a lot faster, because it's just the leftovers from processing that event instead of like everything, right? So that helps. It adds some overhead in other places, but it still ends up being like, that version of it ended up being like 3 times faster. Some of that's going to go away because I didn't have a complete durability or integrity story for that version. You're basically like running naked through, you know, a Middle Eastern city with that, right? Because all it had was the PMA slab. There was no event log or diff log. There were no snapshots. There was optional checkpointing. We don't really want to do checkpointing anymore because it has too many trade-offs and problems that defeat the purpose of doing PMA, which is bringing the amount of heap required to run up here way down, right? So what this branch did is I essentially spec'd out and implemented an event log and snapshotting. And snapshotting is similar to checkpointing, but it's not jam-based. It is just doing like a reflink copy of the PMA slab and PMA meta file. It's way faster, especially if you have fast storage on the machine. Takes very little CPU and RAM as well, because it doesn't have to load or process anything. So the idea is that the event log's a SQLite database. It's like a simple schema. Let me see if I can find my PMA. Nope, hold on. Here we go. Let me find. Okay, so here's the actual like PMA module in Nockchain. So this is an example of like PMA file metadata, PMA trailer, right? They're actually identical. I should deduplicate those. Anyway, there's a magic string at the beginning of a PMA slab, Nock PMA 1, and then 1 is just the PMA version, so we can distinguish them if we ever change the PMA format in the future. PMA itself, we've got an arena, you've got an alloc offset, and then you've got a path to the backing file. So it's doing a shared memory map in order to persist the basically the permanent generation, the parts of the subject that needed to outlive the processing of a particular event. So we still have the knock stack, like that didn't change, right? The difference is that the knock stack itself is now ephemeral. It doesn't just contain everything all at once. It's still anonymous memory map based and everything. It's nothing. I mean, there's been some changes to align it with the. I had already started moving Nockstack towards offset based pointers because I anticipated this work about a year ago. The main relevant changes to the Nockstack are that I basically finished the offset based work to make it compatible with the PMA, and it understands the forwarding pointer scheme. and we need forwarding pointers in the Nock stack because any pointer in a cell that points outside of the current data that's been generated or constructed as part of that event, anything that references like something in the PMA, I use a tracking bit on the pointer to indicate that it's a forwarding pointer that is actually an offset in the PMA rather than something inside the Nock stack. That's the main change to the Nock stack itself. That took some work, but it wasn't bad. Let me see here. Let me check chat, make sure you guys can hear me. Okay. I got a question about whether Logan and I are brothers. No, we're not, to our knowledge, closely related at all. The last name Allen is an old Anglo-Saxon name. It literally just means strong. It's an extremely common name, both in the British Isles and the United States. Allen was one of the top 10 most common surnames among the enlisted in the American Revolution. There were 13,000 men in the U.S. Army at the end of the American Revolution with the name Allen. There were even multiple guys with a name close to Christopher, even though that name wasn't that common back then. Christopher is a little more of a Catholic and Orthodox name. And most of those guys were Protestants, so it was less common back then. Anyway, yeah, no, we're not related. We're just, I mean, we have similar ethnic and familial backgrounds, but our families are from opposite ends of the Appalachian Mountains. I'm from the north. The Allen side of my family, anyway, is from West Virginia, and his is from the south end of the mountains. So we aren't even from the same part of the Appalachians. A similar kind of Anglo-Scots-Irish background, though. I'm not predominantly Anglo-Scots-Irish. I'm actually 2/3 German, 66% exactly. And then I'm I don't know, 25, 23% Anglo and Scots-Irish, and then it's just a long tail of random stuff Finnish. I've got a quantum of North African Arab and Bengali South Asian, 0.2% or something. Mostly German and Anglo and Scots-Irish for me. I think he's more Scots-Irish and Anglo than I am, but I'm not sure of that. Yeah, no, everybody assumes we're related because we have the same last name. It's just a really common last name, especially if you're from the South, the Appalachians, Great Lakes, some parts of the Midwest, that kind of thing. Anyway, so yeah, I've got an event log and snapshotting. So snapshotting is kind of like checkpointing, but it doesn't serialize the entire subject into a jam format, which saves a ton of time and memory and effort. It also means that as long as you don't mind the SSD wear and tear, you can make backups of your subject more frequently, which minimizes what previously with the checkpointing it would have minimized data loss. But the story for this is actually better. So even if you're not creating a new snapshot on every event, you are inserting a new event into the event log, and if your knockout or surf goes down or crashes or you kill it like too abruptly or I don't know whatever it is, right? Um, it can actually recover from the most recent snapshot, and whatever events got processed ahead of that snapshot, it'll just replay the pokes onto the snapshot, and you'll be back to where you started. The goal is basically zero, like data loss or manual, like sync catch up. Obviously, that makes operating appear nicer, but part of what I'm angling at there is I'm trying to make knock apps more trustworthy for non-Nockchain peer type use cases, right? Making the durability story better. So it's not just about bringing RAM usage down and make it easier to run a peer on modest hardware and that kind of thing. It's also trying to make it more trustworthy for ZK app type stuff, or just knock apps more generally. It doesn't have to be a ZK app. Let's see here. So what I'm asking it to do is I'm setting up a benchmark harness that I've actually executed before. I noticed that block 51095 was taking a long time to execute, and let me show you what I mean here. Oh, they changed it. All right, 51095. Okay, you see the ridiculous number of notes in here? All getting consolidated. It was taking peers a good while to poke this block in. It's taking about 130 seconds when I was benchmarking it. And I jetted more tip and gore tip in master in order to make that faster, and I got it down to 36.2 seconds, and 19.6 seconds that was tip 5 hashing. So that's quite a bit faster. I'm using it just as like an anchor for benchmarking the PMA because it's kind of a quick and easy thing to do, relatively speaking. Man, GPT 5.4 has like Alzheimer's or something. This is really annoying. I'm just going to start a new session. Nope. Nope, nope, nope. I do not want to sample compilation. Finish compilation first. This is the native compiler. It's a Hoon compiler written in Rust because I wanted something faster than executing the Hoon compiler from Hoon.Hoon and Nockchain. Currently compiling Hoon 138 takes, I don't know, it depends. Minute and a half to 3 minutes, it depends. Depends on your machine, depends on what version of Nockchain you're using. Anywho, their Urbit's bytecode VM, it's able to compile Hoon 138 in like, I think in my testing it was like 45 seconds to a minute. It can be faster on Apple Silicon because they rely heavily on reference counting. NockVM's generally faster on Linux because it has an architecture that's more efficient in terms of memory bandwidth, and it gets impacted by memory latency less. That is generally better. The reason NockVM isn't faster than Ver, although I have put a fair bit of effort in optimizing it and jetting things, is that the way the interpreter is implemented is relatively naive. The fact that we're like 2.5x slower than Ver right now is actually relatively good for how it's architected. The reason I say that's good is that while being 2.5 times slower than Ver isn't like the best, it's actually fast enough for Nockchain's purposes. But it would be better if it was faster, especially in the area of compiling Hoon code so that it's easier to work on Nock apps and Hoon, right? It impacts us, it impacts anybody downstream in the community, that kind of thing. So I have plans for making NockVM faster, and the reason I say it's good news is because the next steps for making it faster, they're not trivial or easy in any respect, but they are straightforward. Basically, we need to make it a bytecode VM. It doesn't have to work the same way as Ver, but we can take inspiration from that anywhere it seems to make sense to do so. It's not a big deal. Anyway, I'm excited about the native compiler because I think I'm getting close to actually like hitting parity on Hoon 138, which is very exciting because that's not easy to do. And it's pretty fast. So the actual test, like you can see it ran in 48 seconds here. A third of that is the Oracle parity checking that's part of the test harness. The actual compilation time's a little under 30 seconds. So, you know, it's, I don't know, 7-8 times faster than Hoon currently. And it has most things implemented, including mole, wetgate, polymorphism, all that stuff. I'm gonna check the chat, see if anybody has a question. Somebody said, they asked about, you have your own language for Nock, right? Could you talk about that if you can, please? We started working on a language, yeah, called Jock. I'm still talking to Neil about that and things around that. So basically, the only way to generate Nock at the moment is to write Hoon code and compile it with the Hoon compiler from Hoon.Hoon, and then you have two choices of VMs, practically speaking, for running the Hoon compilation. You could use ours, which is NockVM, and if you want to integrate cleanly with our ecosystem, you're going to want to just use Hoon, because we have some special artifacts, jettings, runes, not much, but there's like a little bit there, right? Like we have a special loading arm for the constraints, for example, where we inline them in the kernel so you don't have to queue them in separately when you boot your peer. That's currently your options, right? You can use Urbit and Vir. to compile Hoon to Nock, or you can use our stuff, which is mostly Rust under the hood instead of C. And then we have a couple of just very small kind of augmentations. Also, we're locked into Hoon 138 for a few reasons. Urbit's had a few newer versions of the standard library of Hoon.Hoon since then. I don't actually know what version they're on right now, but the changes aren't really like tremendously important, but yeah, for various reasons it doesn't make sense for us to track or try to upgrade on an ongoing basis. Doesn't mean we won't ever, it's just, it's not worth the risk, basically, for something that pertains to crypto, right? So the idea behind Jock, and what they're asking about is jockling here, right? Here's the repo. So there's like a very early, like kind of alpha implementation here. There's some branches exploring some odds and ends. Let me pull up. Hold on. Let me see if I can read me a roadmap. Notes. There we go. Yeah, so it's a high-level language, compiles directly to Nock. There's a reference implementation that's been started. It's mostly in Hoon. It's just Hoon.Hoon. Hold on. Yeah, so he's got like a tokenizer, parser, branches, comparisons, some operators. It keeps going. Anyway, so the tricky part about designing a language around Nock is that one of the virtues of using Hoon for Nock is that it has relatively little to no impedance mismatch with the actual Nock, because it was designed around Nock from the beginning, right? So what we're trying to do is make something that's a little bit easier for people to read, understand, and use than Hoon. You can just learn Hoon. There's nothing wrong with doing that. Let me show you like some, yeah, Hoon school. Here we go. Yeah, let me show you some Hoon. Okay, chord, basically like a string. Let me show you some real Hoon. Hold on. Give you an idea of what I'm talking about here. Yeah, BIP39. Okay, so this is Hoon. So it's got some inspiration from some areas, and then it's got some stuff that's kind of all its own, right? So it is a pure functional programming language, but it's not tremendously similar to Haskell. For one thing, it doesn't have non-strict semantics like Haskell, and the type system is dramatically different. The kind of bones or skeleton of it are, in some ways, like if you imagined like a Lisp that was built on binary trees directly instead of lists that you could use to represent binary trees. Nock nouns themselves are binary trees. All nouns are binary trees. Everything in Hoon, Nock, all of it is a binary tree, right? Nock has unique properties that make it uncommonly well suited for a ZKVM, and a lot of that has to do with how spare and compact it is. Technically, there's like 12 opcodes. We only really need to support like 10 or 11. Currently, we support 8-ish with a shortcut for 1 or 2 of them, and to get to full ZK apps, we need to make Nock 9 more full fat, basically. And then the hard part is basically Nock 10, which is tree edits. And doing that correctly for ZK proofs is very non-trivial, right? So, yeah, you can definitely just learn this, learn Hoon. If you get like a decent LSP installed in your editor or whatever, it can help you with what the different runes mean. The runes are these diglyphs of like two characters, and they have this this language for referring to them. So like the little pipe character there, they would call that bar, and then the equal sign is tis. So you would refer to this rune as bar tis, right? And this is gonna sound weird. It's a little bit like Chinese characters, where the fact that there's a bar and a tis combined tells you something, kind of like Chinese character radicals, about what it's doing, what it means. The plus sign's referred to as less, so this is less. Percent is sen, so I'm pretty sure this is bar sen, right? This would be tisless. I don't remember what the slash is called, honestly. The question mark is what, and I don't remember what the left caret's called. That is sig, so that would be sig bar. Tis dot. I don't remember what the caret's called. I'd have to look it up. The colon is col, so that would be colsig. Senless. I don't remember what the subtraction sign's called. Let me see if they just have like the runes listed somewhere in here. Okay, yeah. Dollar sign's buck. Slash is fast. Ah, yeah. Caret is ket. Semicolon's mick. Exclamation mark is zap. So zap, all the zap stuff is basically like debugging, error related. So this one produces the Hoon AST of an expression. This is part of like where people kind of, if you squint, it looks kind of like Lisp, because you can actually reflect on the structure or AST of an expression at runtime and like do things with it, right? Zapgar wraps a noun in its type to construct a vase. I mentioned the type system in Hoon is very different from Haskell. A lot of it has to do with the fact that it doesn't really have type erasure, and as constructed, it can't. It relies on runtime type information quite a bit. I don't personally love that. One of my goals for Jock, or just for a Hoon alternative in general, would actually be to try to make a language that's not only easier to write, but that actually compiles and optimizes to more efficient Nock. Now, fortunately, the Urbit developers are working on improvements for optimizing Nock that will help a lot for this, called subject knowledge analysis, SKA. And one of the neat things about the SKA implementation, this is just like an explanation of it that the developer put together, is that it's actually implemented in Hoon. So when it's done and working, we'll be able to just run it in NockVM over the output of Hoonk, essentially, and just see how much faster it makes stuff, which is cool, which is really cool. It'd be really nice to see what it does for Hoonk itself, like the compiler, basically. So you would like do a bootstrap to be able to compile the compiler, you'd run SKA over it, and then you would use that resulting Nock noun for running the compiler to see how much faster it is with SKA. Yeah, Zapgar wraps the noun in its type to make a vase. Zapgar extracts a vase to the given mold of its tightness. Mold. Let me try to find a representative mold. Something that I actually know something about. Yeah. I mean, so like outer fort here is basically like naming fields, types. That at is an aura. as his little tar star thing. Let me see if I can find, okay, auras. There we go. Okay, so at is empty aura, at C is UTF-32, at D is date, at DA is absolute date, at DR is relative date or a time span or duration. We would call duration in Rust. At F is a lubine. So the reason it's called lubine is that it's a Boolean, but the reason the L and B are so strong is that 0 is true and 1 is false, and basically it works kind of like how in POSIX-based systems, exit code 0 is success, right? And then anything else is some kind of error. Lubine really is just 0 or 1, but I get why he did it that way. I think part of the reason why he made lubines where 0 is true is I think it has in part to do with the way sigs and nulls are represented, I believe. But I'm not sure of that. I'm not actually a Hoon expert. I'm actually the systems guy. I just live mostly in the Rust. Anyway, so yeah, these are all like kind of the auras or like scalar types. Something can be. Let's see here. These characters like hep hep, tis tis, those are terminating characters to indicate when something's like done, right? So they're using hep hep here to demonstrate like the end of this definition here, that kind of thing. Let's see here. Anyway, so yeah, I'd like to work on that language. It's just very far from being like a real trustworthy language implementation that's complete. But yeah, I'd like to do something a little more traditional with it as far as like the way it's implemented, the way things at compile time and the runtime work. A lot of the uncertainty there basically comes down to a couple of things. So there's impedance mismatch with Nock itself, right? Because the design of Hoon was definitely like heavily determined by the way the runtime worked, right? And then impedance mismatch with Hoon itself actually does matter. And the reason is because we would like to make it possible for people to be able to incrementally rewrite Hoon programs into Jock. Kind of like how you can incrementally rewrite a C++ application in Rust, right? The catch there is that FFI between the languages has to be reliable and not error prone, and ideally not take a lot of manual effort, right? To do that fully correctly, ideally, your Jock compiler would actually know how to type check and examine the molds of your Hoon code to make sure that your FFI interface type checks across both boundaries in both directions, right? Well, I'm working on a compiler for Hoon in Rust, right? Now, currently, it's a very straightforward translation of Hoon 138's compiler. Because it is hard enough. It is surprisingly hard. It didn't surprise me. I knew how bad it was going to be going in. But it is surprisingly hard if you don't know any better how hard it is to write a Hoon compiler, right? But my long-term goal for the compiler is to be able to split out the not codegen backend into something with its own kind of intermediate representation for not codegen, and then essentially rewrite a Hoon front end for it that is compatible with the existing Hoon compiler, with like ideally like native Rust types, less nouns and things like that. But you know, we'll see. The Hoon compiler definitely relies on like structural equality, unifying equality, merging identical trees and things like that for it to be efficient and correct. If I have a modular compiler with a separate front end and back end, then it becomes a lot easier to write a compiler for Jock as an extra front end to that compiler. And it would just have both front ends available at the same time. And the idea is that I would essentially create like an FFI bridge component in the compiler that would actually know how to use type information from both sides of the FFI so that you don't make any mistakes as much as is possible anyway. That's my goal, but yeah, so basically like I'm trying to make it as like normal and traditional and easy to use as possible, but I have to respect the constraints and parameters of how Nock itself works as like, you know, my runtime target. And then I can't diverge so much from Hoon that it becomes high friction or really difficult to do FFI. One of the main languages that Neil had in mind as like an anchor point for Jock was Swift. And I wouldn't personally mimic Swift in all of the programming language design details and decisions, but one area where I think Swift is particularly exemplary is the effort they went into on the FFI. They put a lot of effort into the FFI for Swift so that it would play nice with the existing Objective-C ecosystem. Let me see if I can find... there's a paper that they actually wrote for FFI and Swift. I don't know if I'm going to be able to find it, but basically it's like an 880-page PDF or something, and it's just about FFI, linking, dynamic linking, stuff like that, and it's pretty cool. It's pretty cool. I don't use Swift personally. I just do everything I do in Rust, basically. I even use it for like browser front-end stuff using Leptos. But there we go. Is a real-time knockup even possible? You have to qualify real-time, and what you mean by real-time, I mean the way knockapps work is like it's not. I don't want to give the impression that it's like a SQL database, but you know, peeks are basically like select statements in a SQL database, and pokes are like you know, transactions that have updates at the end, right? So it might do some read, it might do some compute, and you know, execute some knock or whatever. And then there's like a final, like, it might edit the subject at the end, it might not. It's actually possible to have a poke that doesn't edit the subject at all, and it just computes things. If it doesn't edit the subject, it basically has... Well, no, that's not true. So you can actually... There's a way to perform effects in Nockvm, and it's similar to Ver. Not identical, but it's similar in principle. So you remember how I mentioned that Hoon was purely functional? There's no like formal like I/O kind of baked into the language. Effects are something that you can yield from the Nock runtime, and then your VM, not even your VM, it's actually Knockapp that handles effects basically. Like Nockvm itself is like it has the stuff for that, but you basically have to write effect handlers. If you've ever looked at... Let me check here. Yeah, so you see these drivers, like file here? These are your effect handlers for like file effects and stuff, right? And it pattern matches on the effect event, what operation is doing, that kind of thing, right? The reason I'm talking about this in response to the real-time question is like, as somebody that does a lot of performance engineering in Rust, real-time has like some very narrow constraints and specific meanings to it. When most developers talk about real-time, they're really talking about like incremental event processing, like a soft real-time thing with like some kind of like latency bounding to it, where like it shouldn't take more than like whatever amount of time for it to hit some entry point, and then the final result like comes out the other side after, you know, some maximum amount of time or whatever. Hard real-time would be like fighter jet stuff. You're not going to write any fighter jet software with this, but that's not what it's for. It's not the right tool for that job. But if you wanted to write a Nock app that was ingesting like events from Kafka and processing them in the Nock VM, you could. I don't think you'd want to, um, but you could do the bulk of the compute work in Rust and then poke like final results into the Nock VM if you wanted, for some reason, to leverage. I don't know, maybe you wanted ZK proofs for the event computation or something. You would have to move more of the compute that you want to prove in a ZK app into the Nock at that point, though, because you can only generate a ZK proof for what you actually did inside Nock, basically. Um, it's plausible, though. I mean, it depends on how much work you're trying to do, what you're trying to kind of encompass within the ZK proof, right? Uh, when we process blocks, I mean, when we did the master benchmark, we were doing heavy V2 blocks with a bunch of nodes and transactions. We were hitting 24 blocks per second with master. PMA was hitting 70 blocks per second. That's pretty good. Let me check Rink and see what that is. 1 second divided by 70. So it's like an average of like 14 milliseconds. I mean, that's faster than your typical Rails app, right? I wouldn't call that like real time, but you know, it's I don't think it's problematically so for kind of more ordinary transactional processing type workloads. X42 specification, introduce AI agents holding and spending Nock that become text MV extraction. How will Nock base layer protect those autonomous agents from being front runner exploited? I mean, we've been talking about X402. This is getting out of my realm and into Logan's, I think. This isn't really specific to Nock. This is more of an X402 agent question, I think. Um, Give me 1 second. I will be right back. All right, I'm back. Anyway, so yeah, so for the X402 thing, I don't think there's the question really pertains to Nock. To my understanding, the way people manage the blast radius of an agent sending a bad transaction or whatever is in a couple layers. So one is, let's say you're running a harness for, I don't know, using US dollar coin or something in order to pay for a tool like API calls or whatever. And you're just using X42 to pay for your use of whatever API you're calling. All right, just don't give it a tool for sending arbitrary US dollar coins to arbitrary addresses so that nobody can like figure out how to yield like a poisoned, a prompt poisoning, right? To redirect the money, like just, bury it in the API tool call so that an X402 request only gets submitted for that API usage, right? That would be the most important thing, I think, is kind of cabining like to whom and in what context the request can be emitted, right? And the more you can lock it down or scope it to like, I mean, you're not going to be able to do that in all cases, but basically scoping to like a particular addressee, there's things you can do to validate that there's like a reasonable purpose or proof of the thing you're paying for. So for API calls, you're just kind of trusting the entity serving the API request to like actually serve the request and not take your money for doing nothing. If you don't trust them not to do that, I don't think X402 and the agent really change much. Yeah, I would think the biggest thing is just not like hooking up like an OpenClaw type thing with like arbitrary X402 transaction submission access. Like, don't do that. Another thing people do to limit the blast radius and just to kind of budget it basically is they just have like a wallet specifically for the agent's use that has like a fixed budget, right? So you put like $50 in the bucket or whatever, and then maybe for the first like couple weeks you're operating it, you just monitor the transactions, monitor the budget drawdown, top it off as you see fit, and you don't enable automatic top off until you feel like it's reasonably secure and that kind of thing. I don't to say whether there's something about Nock that would help with this. That would get into it is possible. So if you had full ZK apps and you were doing the X402 transaction in the context of the ZK app. So let's say instead of like calling like a more conventional API provider, right, and then using X402 and US dollar coin to pay for the request or whatever, let's say it's tied to an API request to a ZK app, right? And the ZK app, when it yields the response, it's also yielding a ZK proof of the work it did to serve the response. Essentially, what you could do is you could lock the X402 transaction to the ZK proof verifying, basically. Essentially using the combination of the ZK proof, the ZK app, verification, and the rest of the chain basically functioning as an oracle, right? So it would help with that as long as what you're calling out to is a ZK app. I hope that answers your question. All right, well, let's check in our clankers. See where we landed here. Oh, it's still going. All right. This one's not still going. We'll give that a look later. Renew again. We almost have our checkpoint block benchmark. Okey-dokey. Tis hope, tis loss, tis God. How long has this been running? Just gonna run it myself, see what's going on. Damn. Oh, there it goes. Rough. Queuing's a lot faster than it used to be thanks to chaff. 46 seconds for the checkpoint. Could be worse. Check the comments again. How does Nockchain maintain deterministic block times, correct security thresholds, and levels clean? Still uses hashing. That's an odd question. Oh gosh. Alright, so I just want to say up front, I'm a systems engineer. This is the only time I've ever worked on a crypto thing. I'm not a crypto guy. Logan's better for some of these questions, a lot of these questions. So in general, your mental model for the proof of work chain should be, we are speedrunning the parts of the history of Bitcoin's development that seem to be useful and compatible with what we're doing, right? So we're not hashing. We've got a test puzzle that we're doing ZK proofs on, and that's what we're doing instead of hashing. Partly so that we exercise the ZKVM, obviously, but also because the mining is intended to incentivize the development and refinement of more efficient ZK provers, right? Trying to drive the cost of ZK proofs to zero. The usefulness of the prover work being done on the chain basically hinges on us finishing the ZK VM so that people have non-test puzzle ZK proofs for the miners to verify, right? The ZK apps themselves would presumably be the ones producing the proofs. The miners would essentially function like validator oracles, verifiers, as I understand it, but my understanding is very imperfect and incomplete. I don't. If there's nothing in the mempool, I don't know why you would delay a block. You want to incentivize the miners to stick around, right? And unless they're racing each other to the next block, there's no incentive to make a more efficient ZK prover or ZK verifier, right? That's really all I have for that. Kind of a from left field question. I feel like there's something behind that, but I just don't have context for it. Let's see here. King asked, are we at 16 gigs or 8 gigs? Thanks for the explanation. It depends on how you think about it. So I haven't done the memory limit test myself. My colleague who's working with me on the PMA has. I need to actually run it myself. There we go. 8 seconds, huh? If this is really slow, it just means I need to rebase this on a master, which is fine because I need to do it anyway. It still tells me something when I have the final number. Let's see here. Yeah, so regarding memory, it... Let's see here. I mean, we've got like 2 checkpoints loaded that are like 52,000 blocks each in this benchmark here. And it was using 10 gigs with 2 fairly recent checkpoints loaded simultaneously. I'd call it pretty good. If you aren't running a peer right now and you aren't familiar, Master currently, the steady state, when it's not checkpointing, RSS is like 18, 19, it might be as high as 20 gigs now. But once it starts checkpointing, because it has to load a copy of the entire subject, because we made the checkpointing asynchronous, it happens in the background, so it doesn't block the surf for the whole time it checkpoints, which is not fast. And yeah, it was like 143 seconds, so it's got the old jets, a little bit slower than what I was getting before, but I need to rebase this on the master and refine this a little bit to make sure it's doing what it's supposed to here. Let me rerun this with the improvements it made. I don't think it'll change the actual benchmark time, but it might execute the actual benchmark faster. So the whole subject is on disk. It's we're relying on virtual memory. So like another caveat I should mention, my colleague and I have only tested this on Linux so far. I will be testing this on Mac OS. I just haven't yet, right? I don't have any reason to believe there will be a problem, but no promises until I test it. I do want to be very clear, I will make it work on Mac OS, hell or high water. I know there's a lot of people with Macs. I by default work on Linux just because it's faster for me, usually. in ways that most people don't really notice or care about. But I use Rust in part because I'm kind of a performance fiend, right? So I use Linux. But I do have a new Mac coming in at the end of the month. I got one of the M5 Macs, MacBook Pros. I'm really looking forward to that. Any hoodle. I could do a more heavily restricted memory test with 8 and 4 here in a minute. The way to think about it is that it probably could and should, in principle, work just fine with less memory. What the trade-off you're making is generally going to be throughput. If you keep cold paging stuff like in and out of resident memory to stay within a restrictive memory envelope, and then every time you like peak or process an event or whatever, you have to keep like page faulting stuff that isn't in memory but needs to be for you to like continue what you're doing. That can slow it down because you're basically putting IO events in front of what would normally just be a pointer dereference to another part of memory, right? We did benchmark, my colleague benchmarked it with an 8 gig memory limit, a 4 gig memory limit recently, and the performance seemed fine for a linear poke benchmark. I would expect maybe if you have another pure syncing from Genesis and it's like pulling up a bunch of old chain state history that you cold paged out, that could be slower if you don't have enough RAM to keep it live. I don't know that it would necessarily be brutal though. I plan to benchmark that as well. Having like a fully loaded peer and then an empty peer starting from 0. And I was gonna not only benchmark that and check for like page fault counts and stuff like that, but I was gonna see if like how much a memory limit impacts the throughput. Because like I've mostly been benchmarking writes, like poking new blocks in and stuff, which is like what this guy's doing, right? I want to make like a kind of read heavy benchmark that's just peeking new blocks over and over, essentially. So I'll benchmark it and see. I just don't want to tell people it's definitely going to be fine or definitely going to work if it's like really slow or something, right? That's all. I'm just cautious. It's complicated work, so I just want to be careful. Next question is, what do you think about autonomous AI programming? We'll be able to create different zk-PAB blockchains like Nockchain in a very short period of time, and Nockchain itself become irrelevant. I mean, it could accelerate developing a zk-PAB blockchain. You still have to have human experts in the loop, or the AI will produce garbage for complicated work, basically. Like, okay, let's take this compiler work for example. This compiler work I'm doing here is basically like just beyond the limits of what the AI can really do. I was able to use the LLMs to accelerate the effort. One of my coworkers also, he got this branch started and I kind of picked it up and ran with it for the last mile. It accelerated the effort, but you still need humans who actually understand everything to keep it honest. One of the problems with heavily relying on LLMs is that if you do so on novel subject areas that you don't know well, you're making it easier to deprive yourself of the hands-on experience and know-how required to actually like identify problems, design issues, implementation issues, and fix them, right? You're eating your seed corn, basically. Obviously, I still use LLMs, so clearly I'm not worried about that. But what I do is first I have 16, 17 years experience as a software developer. I'm the oldest person at Zorp right now. I use them to kind of get through the 80/20 part as quickly as possible. I use them to help me with tools, analysis, debugging, uh, test harnesses, like this Nockchain benchmark harness thing, right, for the PMA. And, I've used it a lot for, on the compiler effort as well, but you know, it's like I said, the compiler is kind of just beyond its capabilities. It's the effort's gone a lot slower because the AI just like cannot really do it itself, right? I have to like keep it honest. I have to check its analysis, and like at this point, like I asked it to like fix a problem, and it applied an initial fix, but it still thinks there's a problem in the same like neighborhood, right? I'm getting tired of like spinning my wheels with it at this moment sufficiently that I'm actually just going to just open it up in Zed and look at it myself, right? When you get to the level of like designing a zk-POW blockchain from scratch, however far beyond the and this is GPT 5.4 extra high with 1 million token context window, right? This is the pinnacle of frontier intelligence right now. And it's pretty shaky, pretty bad on the compiler compared to like even the PMA work, right? It was much better at the PMA work than it was the compiler. zk-POW is going to be like 10, 20 times harder. It'll help you write code and stuff, but you need an actual cryptographer, a mathematician who specializes in zero knowledge. You're going to need somebody who understands proof of work chains, all the security concerns and problems around that. You need somebody who understands the intersection of security risks and problems between zero knowledge and proof of work, right? And, you know, I do not have the expertise to finish the ZKVM myself. I'm investigating it, finishing the ZKVM and adding the remaining opcodes and stuff, just because I want to learn more. And I'm doing so with LLMs, but like, I'm not actually qualified to know if it's sound, right? Like either at the level of a spec or a paper, or at the level of an implementation, right? You would be setting yourself up for, if anybody actually trusted you with your vibe coded zk-POW chain, you'd be setting yourself up to be getting embarrassed. More likely, people will ignore it because they'll see that you don't have like a paper from like a real mathematician or cryptographer, right? And if you try to defraud people, nobody will ever trust you again. Yeah, I mean, LMs, in my experience, they help smart people go faster. They don't really replace human intelligence yet. They can solve like rote problems for you quickly, right? But you still need to understand how everything hangs together, even in the simpler stuff. You have to know what you're doing. When we first started leveraging LMs as Zort, it was mostly just me, and some of the other developers would use it here and there, but we had to be really careful because bugs could sneak in. We would catch stuff in code review that looked really bad, right? That kind of thing. And the LMs are good enough that that's not as much of an issue anymore, right? Like they've improved a lot and quickly, but it's still like they're really only trustworthy for very routine work in well-trodden, well-exemplified areas of software work that have like a lot of comparable examples in the training set. And the weirder or more difficult, kind of the more G-loaded basically your problem space is, the less you can trust it. And you have to be like, you have to really understand everything top to bottom. You have to actually be a domain expert to leverage them productively. Or like, for example, let's say you have it design the arithmetic circuits and constraints, for the tables in ZKVM. How do you know if they're sound if you're not a mathematician? Are you just going to like take the model's word for it? Maybe it gets it right. I don't think that's likely. Right? How would you know? I mean, it'll tell you it's got this, low degree set of operations for the compute table and just yada yada and so on and so forth, but you have to have a human actually like design it, think about it, validate it, verify it, all that. I'm not saying it's impossible that somebody could do that someday. I don't think it's super close. And the models have been improving quickly, but the speaking from casual observation, what I mean by casual is from just using them. I don't have like formal evals that I run them through, but just from casual observation of using them, they have gotten better. They still have a lot of problems, and the rate of improvement is not accelerating yet. It might in the future, it's not right now. A lot of the improvements over the last year have been incremental. I would say that the biggest delta is that things that I could previously only trust, say, O1 Pro or O3 Pro with in the past, I can now use normal models for, especially like tricky debugging analysis, performance work, stuff like that. You can do that with more normal, faster models now. I don't think the actual intelligence ceiling has increased by as much. It's just that it is cheaper to do a higher level of intelligence. Now, admittedly, I don't use Pro enough to say that with like a strong degree of certainty because Pro's really slow. I only use it for really deep, difficult work or when my ass is in a sling on some like debugging problem or whatever. And I don't know. I mean, I've had times where Pro got something wrong that a normal model got right, like 5.3 codecs or whatever, right? So I've even seen cases where 5.2 Pro got something wrong that 5.3 codecs got right. I don't take that as an indication of a rapid pace of development from 5.2 Pro to 5.3 codecs, though. I think it's just codecs is refined, more focused reinforcement learning and training for coding. Just makes it more reliable. I don't think it's an intelligence delta. I think it's more of a reliability thing, consistency. Part of it could be the difference between like running it in a TUI harness with tool calls versus like when I prompted 5.2 Pro on that problem, I was trying to give it as complete of a prompt as I could with like all the source code, all the context, right? And I have had problems where doing like a single like big one-shot prompt to Pro solved problems that a TUI harness could not, right? But the gap has closed, basically. I haven't seen the Pro models get noticeably or appreciably better by very much. But again, I have a lot less data on that because Pro's so slow that I don't use it much. Hopefully that answers the question. Checking comments. Thoughts on Nock Rogan? I saw the Avi in Telegram. I don't have any thoughts. Older than Justin. Pretty sure. Don't know for sure. What is it like working with big VCs like Delphi? You'd have to ask Logan, man. I don't talk to the money people. I just work. I'm an IC, man. I don't even mind. I mean, I like knowing the business side stuff, and like Logan keeps us surprised of that. He tells us like, what deals or developer are going through or whatever. He's very transparent about everything with us, but I don't like. I'll join meetings that pertain to engineering with like third parties or business or whatever, just so I can like answer technical questions, limitations, give timelines, that kind of thing. I don't actually want that to be my job. That's Logan's job. I'm happy to let him do that. What I do is a lot more enriching and interesting because part of the reason I work on this is because I get to work on crunchy technical problems and I learn more. That's why I do this. I mean, I want the thing to succeed on its own merits, obviously. That's why this is the first crypto thing I've ever worked on, because I think it's actually doing something useful, right? I care about privacy. Uh, I don't know, I think of ZK as almost like trustless trust, you know? Uh, instead of trust but verify, it's just, you don't have to trust them all, you just verify, right? I'm interested in that for its own sake. Um, but yeah, this is my wheelhouse. I'm happy to stay in it. All right. 135 seconds, yeah, that's on par with the pre-jetting, basically, maybe like 5 seconds more. So I think we're gonna rebase next. Alright, time to rebase. Which means we're cutting a new branch. It's gonna be a fun squash. Go through and do mechanical edits like this, what's the way of forcing myself to refresh my memory of the history I'm squashing. Just getting a event log and snapshot work here. Alright, now we're going to cut a new branch. Yeah, fair enough. Let's see here. Why is this all 1-1? Whoops. Normally I wouldn't do this by hand, I'd just make the LM do it, but I'm just doing it for my edification, basically. Yeah, should be good. Oh, missed one. Huh. Yeah, there's a weird special case for Buctus here. The thing is, if this case is here, there's some test case or something somewhere that necessitated gonna check the comments again. Kang, what did you say WoW for? Well, my coworkers know I'm migrating the PMA to Diesel. takes a hot minute to compile. So whenever I change that, it takes a little bit for it to get to the compiler. Alright. There we go. Yeah. There it goes. Getting the compiler now. Machine I'm running on is fairly powerful. 64 cores, 120 threads, and 9985WX Threadripper. Got 256 gigs of RAM. It says 251. It's like the base 10 versus binary bits thing, I think, or whatever. I don't know. And then I've got a RTX 6000 Pro Max Q edition. It's a 300 watt limited version. It's only a little bit slower than the full power one. Okay, cool. So that parser change did not break anything, right? This error has been around for a while. I just haven't gotten around to fixing it. So that's nominal as far as it goes. So we can just rerun the Win38 compile and see what it does, see if it gives a similar diff. And I'm gonna commit. Barbuck? See, this is what I'm talking about. It's like not checking what I changed, and it's just like hallucinating that there's still a problem here. And you'll notice like there's no real like chain of thought or tool calls here. It's just like answering off the top of its head based on what's in the context window because it thinks it knows everything already. I have to like tell it, like, no, go look at it, it changed, right? This is a relatively trivial like problem, but man, you really have to be careful with these things. They make mistakes all the time. And another thing I've noticed is that they kind of reward hack less in some respects than they used to, but really your expectation shouldn't be that they reward hack less. It's that they are smarter about reward hacking and concealing it from you, right? Which makes it more dangerous, not less. There was actually somebody on Twitter talking about a model doing a very, very clever reward hack trick on an inference performance benchmark. That was scary. Butt call. Okay. Let's look at butt call. Butt call noun, sex noun. Suspect noun. Debug. Yeah. Okay. Some calculations on how much time I'm spending in mole on the compiler. So if 34% is parity checking, then 16% times 1.34 is 21.44. I'll call that 20 to 25%. this is another thing with using LLMs. When the work becomes more precise, takes more care, is more difficult, whatever. I have to start new sessions because the intelligence degrades over the time of as the context window gets longer, basically, and which is a real problem because it's actually pretty hard to get it to like do non-trivial work unless it actually like has all the information it needs in the context window. There's ways to like try to slice and dice that, but it's extremely hard to do with any real precision without like, I don't know, doing like one-shot mega prompts or something. That takes forever. I've done it. Like, I'll just make like a big markdown file with like all the context, all the source code references that are relevant. Sometimes I'll even inline the source code, and then I'll just like one-shot it in like the web chat or something so that it can't total call more source code into the context window or whatever. It's so slow though. It takes forever to put that stuff together correctly, so it's not missing any information. It has strictly only the information it needs, that kind of thing. At that point, it's like, could you just do it by hand? You know, like maybe it can help you investigate, maybe, but yeah. Yeah, I know there's still complex markers, man. All right. Why did I need this? Do I remember why I needed this? Okay. These are very similar. What's going on? Why do we have two of these? Well, they got renamed. Alright. Sample spec, back to 623, coal, factor path sample findings, example back to strongest culprit, and example by coal is the next strongest. Okay. Example. Yeah, example. Okay, so it is suspicious of Batis, an example. It decorates. Jen is a ketos of the skin box example. Bug, not. Alright. And it thinks this diverges from the 38%. It's pretty spare. Let's take a look. Buck tis. Start from the top here. Alright. Buck tis skin and spec. Buck tis mod q.mod. Ketis pmod mod qmod. There's this split thing. There it is. All right. Ketis decorate bug nut clone. Buckloss has a note. Bucktis turns into Ketis with no note. Oh, here's example. Here we go. Alright. Bucktis decorate Ketis pmod example clear mod qmod. Definitely looks similar, but we'll see. Can I shrink this side here? Why isn't it letting me change the size of it? Can I just make you go away? There we go. Alright, bug is a vec of spots. Nut is an option note. Buckless has a note argument. It has a note wrapped around no pmod example mod qmod. Bucktis does not. I don't know if that matters. And decorate is really dumb, which is good. Let's make sure that's the same. There we go. Gen hoon no, not unit. Bug gen debug, bug tbug. Alright. That looks boring in a good way. This is spore. I want an example. There we go. That's auto name. And spec to noun. Wait a second. Hold on. Oh, duh. I have to look for Bucktis to find it. Spec Bucktis. That's example. Okay. If there's a divergence there, it's not obvious to me. Mint Tislas builds from D. Okay. And then I was also interested in buck call. It does not mention the same things as the other session. check comments. Okay, we're pitting 8-4-4-8. And the axe carries Bugnut, Dom, Hancock's, and Death. That's 5. And then you have Keter, Qatar. It's not using that, he's stick example cash, and then hard cuts into the environment. Yeah, that's no bueno. Thinking. Alright, will you crank on that, buddy? Gonna run out of hypothesis meanwhile. Mod 5189. Mod RS. E5189. And it is using spec example cache somewhere. Yeah. Well, if this is real, that was a good get, because it's a very indirect problem that comes from upstream of Mint Tislas. Does this ever get invoked? My goodness. On that module. Alright, I will be right back. Sweet. Same old. We're at 138 now. Oh yeah, I still have the BRB thing on. There we go, I'm gonna get rid of that. Okay. or through 14K. Mostly know the answer to this question. I just want it to think about it instead of me just giving it the answer. This state jam. Do you have a fresh node, or is it just like behind a bit? Can you just let it sync up? Okay, so if you weren't here earlier, working on a native Vim compiler in Rust, and I'm working on the PMA, and currently I'm rebasing the PMA and working through rebase conflicts. Sometime. Okie dokie. Yeah. least 3's in the cache.